Imagine a steel creature the size of a small house rolling slowly across the ground and crushing everything beneath its tracks. A moving fortress that weighs as much as 10 normal tanks put together. Now imagine that this monster is called, with perfect German irony, the Maus. The Panzerkampfwagen Maus was supposed to be the ultimate land battleship of the Third Reich, a tank so heavily armored and so heavily armed that nothing the Allies possessed could even scratch it. Instead, it became one of the most spectacular dead ends in the history of armored warfare. In this story, we are going to walk around that steel colossus, crawl inside its cramped interior, sit next to the engineers who drew its insane outlines, and follow the few prototypes that were ever built, from secret factories to a captured test range and finally to a museum. The Maus is not just a tank. It is a symbol of what happens when ambition, fear, and ideology collide with physics, logistics, and common sense. The deeper you go into its history, the clearer it becomes that this monster never really belonged on a battlefield. It belonged in the dreams and nightmares of the people who ordered it. Our story begins in the dark middle years of the Second World War, when Germany's early victories had stalled and then begun to reverse. In the early campaigns, German tanks had often dominated their opponents with superior tactics and good enough technology. But by the time the fighting in the East turned into a grinding war of attrition, the picture was changing. Soviet factories were pouring out huge numbers of T-34 and heavier machines like the KV series. On the Western Front, British and American tank designs were steadily improving. German crews found themselves facing tougher armor, better guns, and, worst of all, overwhelming numerical superiority. The German answer, encouraged and sometimes demanded by Adolf Hitler himself, was almost always the same. If the enemy has a good tank, build a bigger one. If the enemy has thicker armor, pile on more steel. If the enemy's gun can punch through 100 millimeters of plate, design your own gun to crack 150. Out of this arms race were born vehicles like the Tiger and the King Tiger, machines that terrified Allied crews when they first appeared. They were formidable, but they were also complex, expensive, and mechanically fragile. Each one was a small engineering masterpiece that consumed resources which could have built several simpler tanks. By 1942, this pattern of escalation had taken on a life of its own. The German High Command worried about rumors of even heavier Soviet tanks in development, and Hitler's fascination with giant weapons was only growing stronger. This was the era of 128mm anti-tank guns, railway cannons that fired shells the size of small cars, and rocket-powered aircraft that seemed closer to science fiction than to the reality of bombed-out European cities. It was in this atmosphere that the idea emerged for a truly super-heavy tank, something far beyond the already huge Tiger. The project that would eventually become the Maus began with a deceptively modest concept, a breakthrough tank of around 100 tons, able to withstand almost any existing anti-tank gun and to smash enemy fortifications with a large caliber cannon. Even that weight was already double that of many contemporary tanks, but in the beginning, the designers tried to pretend that this would somehow still be manageable. Speed was not considered essential. Protection and firepower were the gods that ruled the specification sheets. The tank only had to move far enough and fast enough to reach enemy lines and punch a hole through them. Ferdinand Porsche, the brilliant and stubborn engineer whose name today is more associated with sports cars than with tanks, played a central role in the early stages. Porsche had already worked on other heavy tank projects and had a complicated relationship with the German Army's procurement office. Some of his earlier designs had lost out to competing firms, but he remained a favorite of Hitler, who liked his daring ideas and willingness to push beyond conventional limits. When the concept of a 100-ton breakthrough tank appeared, it was almost inevitable that Porsche would be involved. Porsche and his team approached the problem with a mixture of creativity and sheer force of will. If you needed an extremely heavy tank, you could not just scale up existing designs. Everything had to be rethought. The suspension, the tracks, the engine, the transmission, even the basic shape of the hull had to be reimagined to deal with immense loads. Porsche's engineers played with different power plants, including large gasoline and diesel engines, and they quickly realized that a conventional mechanical transmission would be under unbearable stress. Instead, they favored an electric drive system where the engine powered generators that in turn fed electric motors connected to the tracks. On paper, this electric drive had attractive advantages. It allowed smoother control of such a heavy machine and theoretically simplified some mechanical linkages. But it also introduced new layers of complexity, weight, and the constant risk of overheating. Think of the Maus as a rolling power station, a giant internal combustion engine, massive generators, thick cables, and electric motors, all stuffed inside a steel box that weighed far more than any bridge designer had ever planned to carry. The armor requirements climbed almost as fast as the projected weight. Planners wanted a front hull plate thick enough that almost no Allied gun could penetrate it even at close range. That meant armor approaching and even exceeding 20 centimeters in some areas. The turret front had to be even thicker, and within that turret would sit the main gun, at first imagined as a 10.5-centimeter long barreled cannon and later finalized as a powerful 128mm gun with a coaxial 75mm partner. The overall silhouette took shape as something like an armored brick with a huge rectangular turret occupying almost half the length of the hull. The result on the drawing board was impressive in the literal sense of the word. Measuring over 10 meters from front to back and more than 3.5 meters in height, the tank dwarfed anything else in service. The projected weight soared past 100 tons, then 120, then 150. Each time the number crept up, the designers were told to cut it back, but every new feature, every tolerance in armor thickness, every extra round of ammunition pushed it higher again. Eventually, the Maus settled around the figure of roughly 188 tons of steel, machinery, and ambitions. That insane mass had consequences that no one could ignore. Bridges, designed in peacetime to carry civilian traffic or relatively light military vehicles, simply could not be trusted to bear a tank that heavy. The Maus was so massive that German engineers had to accept that it could not use most bridges at all. Instead, it would have to ford rivers using submersible techniques, crawling along the riverbed while a snorkel supplied air to the crew and engine. One can picture the scene, a vehicle taller than a man disappearing beneath the surface of a river, its crew listening to the muffled roar of the engine and praying that no one had miscalculated the depth. Even on land, the Maus would leave a deep trail. Its wide tracks were designed to spread the weight as evenly as possible, but there is only so much you can do when almost 200 tons roll forward. On soft ground, the tracks would bite down mercilessly, churning soil, cracking road surfaces, and potentially bogging down in mud that a lighter tank could simply skim over. Speed was another casualty. At best, even under ideal conditions, the Maus would move at a pace that an average cyclist could match. In real battlefield conditions, with obstacles, rough ground, and the need to maneuver, it would be slower still. Yet inside government offices and at Führer headquarters, the appeal of this steel monster remained strong. The very fact that it was so huge and so heavily armored made it symbolically attractive. It projected an image of invincibility at a time when Germany sorely needed illusions of strength. Hitler, in particular, was fascinated by giant weapons, from the Atlantic Wall to the massive Dora railway gun. The Maus fit perfectly into that psychological landscape. Here was a tank that, on paper, could shrug off any Allied shell and respond with devastating firepower.
The tension between propaganda and practicality appeared early. Some officers in the armored forces and logistics branches were deeply skeptical. They pointed out that every Maus consumed enough fuel, steel, and machine tool hours to produce several more conventional tanks or self-propelled guns. They worried about how such a vehicle could be transported by rail, how it would cross rivers, how it would be recovered if damaged. But those voices were often drowned out by higher-level enthusiasm and by the momentum of the project itself. Once factories begin retooling and materials start flowing, it becomes politically difficult to admit that an idea may be fundamentally flawed. As the first prototype hull neared completion, the reality of the Maus began to overshadow the fantasy. In a testing ground away from the front lines, engineers and soldiers watched as the massive chassis rolled out for its initial trials. Photographs from those days show the vehicle without its turret, an enormous slab of steel with rounded ends and a low profile compared to the final design. Even without the turret, the hull alone weighed more than many full-sized tanks. Drivers learned quickly that this was no ordinary machine. Acceleration was ponderous. Every turn felt like forcing a reluctant giant to change direction. The electric drive system, while conceptually elegant, proved delicate under the brutal conditions of real movement. Heat built up in generators and motors. Complex cooling systems had to work perfectly to prevent failures. Mechanics spent long days crawling through cramped access hatches, checking cables, cleaning contacts, tightening bolts. The Maus was not just heavy in mass, it was heavy in maintenance. A unit equipped with such tanks would need a small army of technicians just to keep them moving. When the first turret was finally mated to a hull and the complete Maus stood on its tracks, the effect was almost surreal. The turret rose like a concrete bunker above the hull, its front plate a sheer wall of armor pierced by the enormous muzzle of the 128mm gun and the smaller coaxial cannon beside it. Inside that turret, the crew had to work around the massive breech blocks, ammunition racks, and recoil mechanisms. Despite the overall size of the vehicle, the actual working space for the men was limited. Steel ate the volume. Armor, guns, and machinery claimed most of the interior. What remained for human beings were narrow passages and positions that required stooping, twisting, and constant awareness of moving parts. Consider the job of a loader. A single shell for the main gun was a double-piece affair with a heavy projectile and a separate cartridge case containing propellant. Each piece weighed enough that handling them repeatedly over a long battle would exhaust even a strong, well-trained man. In theory, the Maus could devastate enemy forces with a few well-placed shots. In practice, the crew inside the turret would be performing a brutal workout under stress, heat, and noise, all while confined in a steel box that enemies would do anything to destroy. Test firing the gun was a spectacle in itself. At the proving ground, with observers at what they hoped was a safe distance, the Maus lined up on target hulks made from old tank armor and concrete. When the commander gave the order and the gunner squeezed the trigger, the gun barked with a thunderous report that rolled across the landscape. The recoil pushed back through the turret and into the hull, making the whole vehicle shudder. Dust and smoke wrapped it in a temporary cloud. Downrange, the shell smashed into its target with catastrophic results, tearing through thick armor in ways that made even hardened observers whistle softly. There was no question that the Maus could deliver a terrifying punch.
The question was whether it could do so often enough, in the right place, and at a sustainable cost. Every kilometer it traveled on its tracks ate into its limited mechanical life. Every time the gun fired, stresses rippled through complex systems that were already operating near their limits. The Maus was like a heavyweight boxer who could shatter bones with a single blow, but tired quickly and needed a whole team just to get into the ring. As the war dragged on and German forces retreated on multiple fronts, the dream of deploying Maus battalions to spearhead counterattacks became more and more unrealistic. The front line was far away from the factories and testing grounds where the prototypes crawled along. Allied bombing campaigns disrupted production, destroyed infrastructure, and forced the relocation of key industries. Resources that might have gone into full-scale Maus manufacturing were desperately needed for aircraft, submarines, and replacement parts for existing tanks. Inside the German command structure, the mood shifted. What had once been an exciting experimental project began to look like an indulgence. The sheer scale of the Maus made every problem harder. Transporting it by rail required specially modified cars and careful planning. Even then, the tank might be too wide or too heavy for some stretches of track and some bridges. And yet, people continued to work on it. Engineers who had devoted years to the design were reluctant to see it abandoned. There was professional pride at stake. Technicians who had mastered its quirks felt a certain grim affection for the machine. Soldiers who climbed into its turret for tests could not help but feel a sense of awe at the thickness of the armor and the size of the gun. Even as the front collapsed, there was still a faint hope in some minds that maybe, just maybe, a handful of these tanks could appear in some critical sector and turn the tide. That hope never had a chance to be tested. Only a couple of Maus hulls and a single complete turret were finished before the war in Europe ended. Soviet troops advancing into German territory captured the testing grounds where the prototypes had been assembled. For them, finding this monstrous machine must have felt like stumbling upon a lost chapter of a mad science novel. Here was the culmination of German obsession with heavy armor and massive guns, sitting silent and unfinished as the Third Reich crumbled around it. The Soviets were not about to pass up the opportunity to study such an unusual vehicle. They arranged for one of the hulls and the completed turret to be combined into a single operational specimen, at least in the sense that it could be moved and examined. This cobbled-together Maus was then transported to the Soviet Union, where engineers and military analysts could inspect it at leisure. They measured armor thickness, peered into the electric drive system, weighed the huge shells, and asked themselves whether such a tank made sense in their own doctrine. The answer was, unsurprisingly, no. Soviet tank design favored mass production, mobility, and good enough protection rather than chasing absolute extremes. While Soviet engineers respected the technical achievements represented by the Maus, they also saw its crippling limitations. A tank that weighs nearly 200 tons is not a practical battlefield tool. It is a technological curiosity. The Soviet Union would go on to experiment with heavy tanks of its own, but nothing approached the sheer mass of the Maus. In the post-war years, the surviving Maus prototype eventually made its way to a museum, where it still stands today as a silent witness to the era that created it. Visitors walk up to it and instinctively reach out to touch the armor, feeling the cool, slightly rough surface of steel that once defied almost every weapon of its time. Many people find themselves dwarfed by the tracks alone, which rise higher than their shoulders. Looking up at the turret, they see not a sleek weapon of war, but a squat fortress, a bunker on tracks. Standing next to it, it is easy to imagine the reactions of Allied tank crews who might have had to face such a machine in combat. The first glance would inspire fear. The second would prompt questions. How fast can it move? Where can it go? How often can it fire before something breaks? How many of them can the enemy really afford to build? In those questions lies the key to the Maus story. It was not the tank that Germany needed in the desperate final years of the war. It was the tank that embodied a refusal to accept the realities of industrial warfare. The economic contrast is brutal. For the steel and labor required to build a single Maus, German factories could have produced several Panthers or a whole swarm of simpler assault guns and anti-tank weapons. Each of those smaller vehicles would have been easier to transport, easier to repair, and more likely to be where they were needed when they were needed. In a war where logistics and numbers increasingly determined outcomes, pouring resources into a handful of gigantic tanks was a form of self-inflicted wound. There is also a haunting historical irony at work. The Maus was conceived as a breakthrough weapon, a tank that would smash through enemy lines and lead German forces to victory. Instead, it never fired a shot in anger, never led a charge, never even reached a battlefield. The only breakthrough it achieved was in demonstrating that there is a point where bigger and heavier stop being advantages and turn into liabilities. The super heavy tank project was canceled not because the enemy destroyed it, but because reality did. The men behind the Maus went on with their lives in different ways. Some continued to work in engineering fields after the war, applying their skills to civilian projects or to more sensible military designs. Others faded into obscurity. Porsche himself would eventually see his name become synonymous with sleek sports cars rather than with monstrous tanks. For many of them, the Maus must have been a mixture of pride and regret. Pride in the technical accomplishments, regret that so much effort had gone into something strategically pointless. Today, when visitors at the museum walk around the Maus, they often hear guides telling the story of its creation and failure as a cautionary tale. People run their hands along the armor and listen to how this incredible thickness did not save Germany from defeat. They peer into the openings and imagine the cramped positions of the crew. They step back and take photographs, trying to fit the whole vehicle into the frame. In those moments, the Maus becomes more than an oversized machine. It becomes a tangible lesson. The lesson is not simply that war is destructive or that dictators like big toys. The deeper message is that in warfare, as in engineering, obsession with extremes can blind decision-makers to practical realities. A weapon is only as useful as the strategy, logistics, and doctrine that surround it. An invulnerable tank that cannot reach the right place at the right time is less valuable than a modest tank that can. The Maus pushed every parameter of size, armor, and firepower to astonishing levels, and in doing so, crossed the invisible line where effectiveness begins to fall instead of rise. If you enjoyed this deep dive into the story of the Maus, the biggest tank that never saw combat, consider supporting the channel. Leave a like if you want more long, detailed videos about strange and ambitious war machines that almost changed history. Tell us in the comments which experimental tanks, aircraft, or ships you would like to see covered next, from forgotten prototypes to legendary monsters. And do not forget to subscribe, so you will be here for our next journey into the world of military technology, where genius, desperation, and reality meet.